Okay, hello ladies and gentlemen. We are still continuing with exponents. So we're going to solve this expression for grade 11 and grade 12. Alright. So once you get in this type of expression, look what is inside the brackets and now we want to simplify. And then you find that okay, there are common bases here. And then we can start with bases. Yes, we start with simplifying bases. So let's simplify. Okay, let's rewrite it. A to the power 6, b to the power minus 2 divided by 27, a to the power minus 3, b to the power minus 2, all in brackets, to the power 2 over 3. Now, look at this expression. So you see, a is the same base with this one, b is the same base with this one. So in exponents, so we're doing for grade 11 and 12. So in exponents, in a multiplication, you can separate the powers that are on the denominator to the powers that are on the numerator. How? Let's show it. So we're going to have 8 over. It's like we're collecting the like terms, but in this case, we're separating powers to the powers of the numerator. So we've got a, and then we separate powers with the same base. Okay, so it's 6 minus this one minus 3 times b, this one minus 2 and minus 2. Okay. Okay. Okay, let's start again from this step. Let's start again. Something that is not clear. Okay, we're saying we're going to subtract the powers from the numerator to the powers on the denominator. That is with powers that are having the same basis. Okay, so it's 8a to the power 6 minus into minus 3. This one times b, this one to the power minus 2 minus into minus 2, and then divide by, now we're going to left with 27 here over 27, and then don't forget your powers that are outside the brackets, 2 over 3. Now let's work on inside the inside the bracket. So 6 minus 10 minus is positive, so we're going to have 6 plus 3, which is 9. So we're having 8 to the power 8a to the power 9 times b to the power minus 2, okay, minus 2 and minus 10 minus 2, it will be a positive. So minus 2 plus 2 is 0. And then we're going to have 27 here. Do not forget your the power 2 over 3. Okay, now at least it's simpler now. So we know that in exponents, anything that is to the power 0, it's 1. So here we're having 8 over 9. So times 1 divided by 27, all into 2 to the power 3. Okay, let's continue here. So we're having 8 to the power 9 and 27. Now we can break down 8 and 27 into an exponential form. Okay, so 8 is going to be 2 to the power 3. 27 is going to be 3 to the power 3. And then a to the power 9, and then we all multiply by 2 to the power 3, 2 over 3. So here we can multiply all the coefficients that are inside, or the bases that are inside, with 2 over 3. So we are going to multiply 2 over 3 in exponents inside the bracket. So we're going to have 2 over 3 times 2 over 3, this one, times a, this one, 9 times 2 over 3, divide by 3 to the power 3 times 2 over 3. Okay, now if we look here, this can cancel this, and then we left with 2 to the power 2, and then a, this goes 1, and then here 3 6 goes to 3 times, 3 times, so having 3 times 2, which is 6, divide by this, cancel this, and then we're left with 3 to the power 2, and then the final answer will be 4 a to the power 6 divided by 3 times, which is 9. This is our final answer. So if you break down, okay, let's make it briefly. From here, you ensure that you write it as it is, and then you subtract the powers of the same base here. And then once you subtract it, you make it simple. And then once it is simple, ensure that all the numbers, you put it in an exponential form. So 8 and 27 will be 2 to the power 3 and 3 to the power 3. And then you look inside the bracket, and then you can simplify it, and then you multiply with that power 2 over 3, all the powers that are inside the brackets, and then you cancel, and then we say 3 divided by 3, and then these are cancel each other. This will cancel this one, and then left with 2 to the power 2 and 8 to the power 3 times 2, which is 6. And then so the final answer is 2 to the power 2a over 6 divided by 3 to the power 2, which is 4 and 9. So our final answer is 4a to the power 6. That's it. Thank you.